what does light see when it moves through the universe? Not colors, not shapes, not borders like we do. Imagine a beam leaving a distant star, slipping past planets, dust, and empty space, carrying a quiet record of everything it touches. To us, it looks simple, just brightness. To physics, it's a messenger with timing, energy, and direction written into every wave. As we slow down and pay attention to that message, whole structures appear, orbits, distances, even the shape of space-time itself. If you enjoy this kind of calm exploration where we take one idea and follow it carefully, a small like and subscribe helps this little corner of science reach more curious minds. Get comfortable, let your thoughts settle, and we'll ask a strange question together. From light's point of view, what does reality look like? In our standard experience of reality, motion is always relative. When you travel down a highway, the world outside your window appears to rush backward solely because of your own momentum. If you accelerate, you overtake slower vehicles. If you decelerate, they pass you. This logic governs everything from a stone thrown across a lake to a jet moving through the stratosphere. Speed is simply a comparison between two objects. However, light refuses to adhere to this intuitive framework. It behaves unlike anything else in the physical world. To understand the nature of the universe, one must first accept a fundamental and counterintuitive fact. Light cannot be overtaken. Imagine a scenario where you could travel at incredible velocities, pushing engines to their breaking point. Logic suggests that as you accelerate, the beam of light ahead of you should appear to slow down, much like another car on the road would as you draw near. Yet, physics dictates a different outcome. Whether you are standing perfectly still or hurtling through the cosmos at 50,000 miles per hour, a beam of light will recede from you at the exact same rate. It maintains a constant, unyielding gap. Light does not meet the observer halfway. It operates independently of the observer's motion. This absolute constancy is not merely a curious detail. It is the mechanism that forces space and time to distort. Because light refuses to change its speed to accommodate us, time itself must slow down, and space must contract to keep the equations balanced. This phenomenon leads us to the edge of human comprehension regarding time. Light is not simply moving quickly. It is moving at the maximum limit permitted by the laws of physics. Because it travels at this ultimate threshold, the rules of time that govern biological life cease to apply to the photon itself. If one were to theoretically assume the perspective of a particle of light, the concept of duration would vanish. For a human, traversing the distance between a star and a planet requires a massive investment of time. We measure the journey in years or centuries. However, for the light beam itself, the journey is instantaneous. The moment of emission from a dying star and the moment of absorption by a telescope on Earth are, to the photon, the exact same event. Distance collapses into nothingness. This creates a profound disconnect between our perception of the universe and the reality of the signal carrier. We live trapped within the flow of time, measuring existence in seconds, hours, and epochs. We require these intervals to process cause and effect. Light, conversely, exists in an eternal, singular now. When we ask what light sees, we are attempting to understand a state of existence where the separation between departure and arrival does not exist. Yet, despite its timeless nature, light acts as the primary clock for the cosmos. It connects isolated galaxies and allows us to perceive the architecture of space. It is the courier of history. When we observe a celestial object located thousands of light years away, we are not seeing the object as it exists today. We are witnessing a ghost, an image preserved by photons that have traversed the vacuum for millennia. These particles carry the data of a past era, unaffected by the rise and fall of civilizations that occurred during their transit. They deliver a visual echo of the universe's history, allowing us to look backward in time simply by looking up. This function is crucial because it reveals that the universe is built upon a delay. We never see the present moment of the cosmos. We only see layers of the past, arriving at different times. This brings us to the structure of information itself. The universe relies on light to communicate. Think of a disturbance on a calm body of water, a ripple expanding outward from a single point. That ripple carries energy across the surface, affecting everything it touches. Light functions similarly, but it is a ripple in the electromagnetic field. It is the pulse of reality. Whether a star explodes, a black hole merges, or a chemical reaction occurs on a distant world, the news of that event spreads outward at a specific, unbreakable pace. This consistency is absolute. The speed of this pulse does not fluctuate based on temperature, wind resistance, or the motion of the source. A flashlight turned on inside a speeding spacecraft emits light that travels at the same velocity as a flashlight turned on the ground. We have measured this velocity with extreme precision. In a vacuum, light travels at exactly 299,792,458 meters per second. In imperial units, this equates to roughly 186,282 miles per second. This number is so immense that it effectively renders terrestrial distances meaningless. Light could circle the Earth 7.5 times in a single second. Yet, on the cosmic scale, it is finite. It is a distinct limit. This specific number, which physicists denote as c, is the foundational constant of modern physics. It acts as the anchor for our understanding of mass and energy. The implications of this finite speed are far-reaching. Because the speed of light is invariant, meaning it never changes, regardless of who is measuring it, it forces us to redefine what we mean by speed. It is not just a measure of motion, it is the speed of causality. It is the maximum speed at which 2 points in the universe can affect one another. Information cannot teleport, it must travel. Therefore, the speed of light is actually the speed limit of information. Nothing in the universe, no matter how violent or powerful, can transmit a signal faster than this limit. This realization overturned centuries of classical mechanics. Before we understood this constant, we believed time was a steady drumbeat that ticked the same for everyone. We now know that time is flexible, tethered directly to the motion of light. The constancy of light is the reason that as objects approach this speed limit, their mass increases towards infinity and their passage through time grinds to a halt. It defines the boundaries of the possible. It establishes a strict cosmic horizon. No particle with mass can ever reach this velocity, and absolutely no spaceship, regardless of its engineering, can ever exceed it. One of the most unsettling realizations in physics is that light appears to be completely indifferent to the existence of time. While the universe ages around it, evolving from primordial gas into stars and galaxies, light itself remains suspended in a state of perpetual immediacy. It exists in an eternal now, never experiencing a past or a future, simply persisting in its trajectory. To understand how this is possible, we must first look at what light actually is. It is not a solid object like a vehicle or a projectile that requires an engine to accelerate or brakes to decelerate. It does not struggle against friction or inertia. Instead, light is a self-sustaining wave in the electromagnetic field. It is a disturbance of pure energy. Because of this nature, light does not need to ramp up to its speed. A car must gradually build velocity, but a photon is born instantly traveling at top speed. From the exact moment of its creation, whether in the fusion core of a star or the filament of a light bulb, it is already moving at exactly 299,792,458 meters per second. It will maintain this velocity indefinitely as long as it travels through a vacuum. It effectively has no rest state. Light is either moving at the speed of light or it does not exist. This constant velocity is not merely a trait of the photon. It is a fundamental setting of the cosmos, as integral to reality as gravity or mass. If this constant were to fluctuate even slightly, atomic bonds would destabilize, and the structure of matter as we know it would unravel. This consistency provides a strange sort of reliable anchor in a chaotic universe. While planets shift orbits and stars burn out, the speed of light remains absolute. This brings us to the perspective of the photon itself, a perspective that defies human intuition. We are biological entities hardwired to perceive time. We live by the ticking of seconds. We endure the sensation of waiting. We perceive duration as a tangible distance between events. But according to the principles of special relativity, time slows down as velocity increases. At the speed of light, time effectively stops completely. If you could theoretically attach a camera to a photon, the footage it recorded would be incomprehensible. Since time halts at light speed, the photon does not experience the journey. Consider a photon emitted from a galaxy billions of light years away, traveling across the dark void to reach a telescope on Earth. To us, that journey took billions of years. Civilizations rose and fell while that light was in transit. But for the photon, the emission and the arrival happened at the exact same instant. There was no interval, there was no transit time. The moment it left the star was the same moment it struck the telescope's mirror. In the frame of reference of light, the universe is not a place where things happen in sequence. It is a place where departure and arrival are fused into a single point. This leads to a phenomenon known as length contraction. As an object approaches the speed of light, space itself begins to compress in the direction of motion. For us, moving at slow terrestrial speeds, the distance to the Alpha Centauri star system is roughly 4 light years, a vast chasm of space that would take current spacecraft tens of thousands of years to cross. However, as you accelerate closer to the speed of light, that distance physically shrinks from your perspective. If you could reach the speed of light, that distance would shrink to 0. This is why we say light does not experience distance. For a photon, the dimension of space in its direction of travel collapses entirely. It does not traverse the gap between stars. For the photon, the gap does not exist. The universe, which appears to us as a vast, empty expanse separating objects, is, to a beam of light, a singular, connected point. This is a radical departure from our biological reality. We are defined by separation, the distance between home and work, the time between now and later. Our entire existence is structured around navigating these gaps. Light, however, bypasses them entirely. It is difficult to truly visualize a universe without waiting. We are creatures of duration. We wait for chemical reactions to finish, for signals to transmit, for bodies to age. We view time as a river that carries us forward, but light stands outside this river. It is an observer that sees the beginning and the end simultaneously. This timelessness is what allows us to see the universe at all. If photons aged or decayed over time, the light from distant galaxies would never reach us intact. The image would degrade. But because light is timeless, it preserves the information it carries perfectly across any distance. The image of a distant nebula is delivered to our retinas with the same fidelity as when it was created, precisely because the carrier of that image has not experienced the passage of time. This concept challenges our definition of reality. We assume that time and space are fixed stages upon which events occur, but light reveals that they are malleable. They are flexible fabrics that stretch and warp depending on how fast you are moving. The faster you go, the more the universe compacts around you. If you were to travel at light speed, the entire universe in your path would flatten into a two-dimensional plane. You would be everywhere along your path at once. This is not science fiction. This is the mathematical reality described by Einstein's field equations. So, when we look up at the night sky, we are looking at a paradox. We see a vast, deep dome of stars, separated by unimaginable distances that take eons to cross. That is our reality, but hidden within that view is the reality of the light itself, a reality where there is no depth, no time, and no distance. The light entering your eye has effectively teleported across the universe in its own frame of reference, bridging the gap between a nuclear furnace deep in space and a biological nerve ending on Earth in zero time. It is a reminder that our perception of the world as a place of ticking clocks and measured miles is just one way of viewing the cosmos. There is another view, the view of light, where the universe is a single, immediate, and interconnected event. This phenomenon of space contraction is not just a theoretical curiosity. It has practical implications for how we understand cosmic travel. It implies that the barrier to exploring the stars is not just the engineering challenge of building fast engines, but the fundamental geometry of the universe. We are locked in a slow-moving reference frame where distances are maximized and time is elongated. We are, in a sense, trapped in the slow lane of reality, forced to experience the universe as a vast, empty place, while light zips through a collapsed, immediate version of the same cosmos. As we continue to probe these concepts, we begin to see that speed is perhaps the wrong word for what light possesses. It is not just moving fast, it is defining the structure of causality. It dictates how parts of the universe relate to one another. It is the cosmic speed limit not because it is arbitrary, but because it represents the limit of how instantaneous reality can be. To go any faster would be to arrive before you left, to violate the sequence of cause and effect. Light sits exactly on that edge, the boundary between the flow of time and the stillness of eternity. Let us deepen our experiment by stepping away from the abstract nature of a photon and placing ourselves inside the cockpit of a theoretical spacecraft. Imagine this vessel is capable of reaching velocities that approach the cosmic limit, say 99.9% of the speed of light. As we engage the engines and accelerate away from Earth, the universe outside begins to transform in ways that defy common sense. We are entering the realm of relativistic physics, where the rigid structures of space and time begin to melt. The first thing you, the traveler, would notice is the distortion of the star field ahead. Due to a phenomenon called aberration, the stars would appear to cluster directly in front of your ship, as if the tunnel of space you are moving through is narrowing. But more profoundly, the physical distance to your destination would shrink. If you were heading toward a star 10 light years away at this immense speed, the journey would not feel like 10 years to you. Because of length contraction, the space between Earth and that star would physically compress for you. You might arrive in what feels like a few weeks or even days. To your perception, you have simply covered a short distance quickly. However, this is where the paradox of relativity reveals its teeth. While you are experiencing a short, manageable trip, the clocks back on Earth are ticking at their standard rate. For the mission control team watching you leave, your ship is moving just under the speed of light. To them, the journey to a star 10 light years away must take slightly more than 10 years. There is no way around that math. So, when you arrive and send a signal back, or turn around and return home, you will find a disconnect. You have aged only a few weeks. The people you left behind have aged a decade. This is time dilation in action. It is not an illusion or a trick of the mind. It is a physical reality. Speed effectively acts as a brake on the flow of time. The faster you move through space, the slower you move through time. It is a zero-sum game. We are all traveling through space-time at a constant rate. When we are sitting still, all of that travel is dedicated to moving forward through time. We age at the maximum speed. But when we divert our motion into traveling through space, we must borrow from our motion through time. At 99% of light speed, you are using almost all your capacity to move across space, leaving almost nothing left for time. Now, extend this logic to the limit. What happens if you push all the way to 100%? This brings us back to the photon. A photon uses all of its motion potential to travel through space. It has absolutely no motion left for time. This is why time stops completely for light. For a photon, the concept of a journey is mathematically undefined. It does not experience the billions of years it takes to cross a galaxy. It does not wait to arrive. In its frame of reference, the moment of creation and the moment of destruction are superimposed. This creates a jarring duality in how the universe is constructed. We, the observers made of matter, live in a universe of sequences. We see cause, then delay, then effect. We see a star explode, and then, thousands of years later, we see the light arrive. We are trapped in the chronological narrative. Light, however, exists in a universe of immediacy. It stitches the cosmos together without the lag of time. When we gaze up at the night sky, we are essentially accessing this timeless network. The light hitting your retina is a direct physical link to the past, delivered instantly from the photon's perspective. Consider what this means for our view of history. We often say that looking at the stars is like looking back in time. That is true, but it is deeper than that. We are seeing a memory of the universe that is being delivered to us live. The light carrying the image of a galaxy from the dawn of time has not aged a single day during its transit. It has held that image perfectly frozen. It is a witness that does not degrade. If light experienced time, if it could age or change during its journey, the information it carries would be corrupted. We would look up and see a blur, a faded echo. Instead, we see the universe exactly as it was, preserved in the amber of light speed. This unyielding speed leads us to reconsider the nature of now. We intuitively think that now is the same for everyone. We imagine a universal clock ticking in the background, but relativity shatters this comfortable idea. There is no universal now. My now is different from the now of a spaceship zooming past Mars, which is different from the now of a photon. The universe is a collection of fragmented timelines, all running at different speeds, stitched together only by the constant speed of light. Light is the only thing that everyone agrees on. It is the invariant ruler against which all other realities are measured. If you were to embody a photon, you would possess a strange kind of omniscience regarding your own path. Since you do not experience time, you are essentially at your origin and your destination simultaneously. The vast void of space that terrifies human travelers, the emptiness that isolates solar systems, is irrelevant to you. You bridge the gap without traversing it. This suggests that from the perspective of light, the universe is not a vast, empty cavern. It is a tightly connected web where every point is in contact with every other point it can reach. We struggle with this because our biology is enslaved to entropy and thermodynamics. We eat, we sleep, we degrade. We are processes that require time to function. A thought takes time. A heartbeat takes time. Therefore, we cannot truly comprehend an existence where time is absent. It feels like death to us. But for light, it is simply the state of being. It is a state of pure energy, unburdened by the heavy anchor of mass that drags us down into the stream of time. This difference in perspective highlights the fundamental separation between matter and energy. Matter, the stuff we are made of, is sluggish. It resists motion. It clings to time. Energy, in the form of light, is liberated. It moves at the maximum possible speed and sheds the constraints of chronology. When we build particle accelerators and smash atoms together near the speed of light, we are trying to force matter to behave like energy. We pump massive amounts of power into these particles, pushing them closer and closer to that limit. And what do we see? Their time slows down. They survive longer than they should. We can physically measure their lifespans extending, proving that these strange rules are not just theories on a chalkboard. They are the engineering blueprints of reality. So, as we contemplate the nature of light, we must accept that our human experience is the exception, not the rule. Most of the universe is empty space filled with radiation moving at light speed. The normal state of the cosmos is one of timeless, high-speed connection. We, huddled on our slow-moving rock, circling a slow-moving star, are the anomalies. We are the ones trapped in the slow lane, watching the universe rush by in a blur of radiation. We invent clocks to make sense of our slowness. Light needs no such device. In the end, the speed of light is not just a number 299,792,458 meters per second. It is the horizon of causality. It is the boundary that defines what is knowable. Anything happening outside this speed, outside the light cone of our location, is effectively cut off from us. We can only know what light has had time to tell us. And because light takes no time to tell it from its own perspective, but takes ages to reach us from ours, we live in a permanent state of delay. We are always waiting for the news of the universe to arrive. This is the profound melancholy and beauty of astronomy. We are always looking at ghosts. We are always studying the past. But thanks to the timeless nature of the photon, those ghosts are real. They are not reconstructions or simulations. They are the actual physical touch of the past, reaching out across the vacuum to interact with us in our present. The photon that hits your eye tonight really was there in the heart of the Orion Nebula or the surface of Andromeda, and it has brought that reality to you, unchanged, unspoken, and eternal. We have established that for a photon, the concept of a journey is an illusion. Since it does not experience time, the departure and the arrival are fused into a single event. It is a traveler that never actually feels the sensation of travel. But this raises a fundamental question for us, the inhabitants of the physical world. Why are we denied this privilege? Why must we endure the slow, grinding passage of time? Why can we not simply accelerate our ships to the cosmic limit and slip into that timeless state? The answer lies in one stubborn, inescapable property: mass. Mass is often misunderstood simply as weight, but in physics, it is much more profound. Mass is essentially a measure of resistance. It is a measure of how much the universe wants you to stay put. Everything you can touch, your body, the chair you are sitting on, the planet Earth itself possesses mass. This means we are anchored to the fabric of space-time. We create a drag as we move through it. To move an object with mass, you must apply force. You must burn fuel to fight against its natural tendency to remain still. Light, however, is born without this burden. A photon is massless. It has no resistance, no inertia, and no anchor. Because it has zero mass, it does not need to accelerate in the traditional sense. It does not need an engine to ramp up its speed. The moment it exists, it is already moving at the maximum speed allowed by the universe. It cannot move slower. To have zero mass is to be compelled to move at the speed of light. There is no other option. For us, the story is different. Because we have mass, we are locked in a struggle with energy. As you push an object faster, you must feed it more energy. This is intuitive. A car needs more gas to go faster. But as you approach the speed of light, the equations of relativity introduce a terrifying exponential curve. As a spaceship accelerates toward 99% of light speed, its mass effectively begins to increase. The energy you pump into the engines doesn't just make the ship go faster, it makes the ship heavier in terms of inertia. The closer you get to the speed of light, the heavier you become, and the more energy you need to gain just a tiny bit more speed. It becomes a vicious cycle. By the time you reach 99.999% of the speed of light, your ship would behave as if it had the mass of a planet. To push it that final tiny fraction to reach 100%, you would need an infinite amount of energy. Since there is not an infinite amount of energy in the universe, the conclusion is absolute. Matter can never reach the speed of light. We are forever barred from that timeless realm. This creates a strict segregation in the cosmos. On one side, there is the realm of mass. This is our world. It is the world of atoms, stars, planets, and people. It is a world defined by slowness, by the passage of time, and by the capability to stand still. We can stop, we can wait, we can age. On the other side is the realm of light, or radiation. This is the world of photons, gluons, and gravitational waves. It is a world of zero mass, maximum speed, and zero time. The two realms interact. Matter emits light, and light hits matter, but they operate under entirely different sets of rules. This distinction explains why we feel the passage of time so acutely. We are dragged through time because we cannot move fast enough through space to escape it. Mass acts like a heavy keel on a boat, keeping us steady in the flow of time. Light has no keel. It skims the surface, bypassing the current entirely. This relationship between mass and spacetime goes even deeper when we consider gravity. Einstein taught us that gravity is not a magical force pulling things together. It is the curvature of space and time caused by mass. A massive object like the Earth sits in the fabric of space like a bowling ball on a trampoline, creating a dip. When we walk on the ground, we are sliding into that dip. Now, consider how light interacts with this. Since light has no mass, you might think it would ignore gravity. After all, if gravity pulls on heavy things, why would it pull on a massless photon? But because gravity warps the road itself, the space that light travels through, light does curve. When a beam of light passes a massive star, it bends, not because the star is pulling the photon, but because the star has bent the straight line the photon was traveling on. The photon is still thinking it is going straight, but to us, it arcs. However, even though light follows the curves of gravity, it does not succumb to the slowing effects of it in the way matter does. If you throw a ball upward, Earth's gravity slows it down until it stops and falls back. Gravity steals its kinetic energy, but you cannot slow down light. If you shine a flashlight upward from a black hole, the light struggles against gravity, but it does not slow down. It will always travel at c. Instead of losing speed, it loses energy by changing color, shifting toward the red end of the spectrum. It is a phenomenon called gravitational redshift. The light pays its tax to gravity, not by slowing down, but by stretching out. This reinforces the unique status of light. It is the only thing in the universe that refuses to compromise on speed. It will change its color, it will bend its path, it will distort its frequency, but it will never, ever slow down in a vacuum. It preserves its timeless nature at all costs. This separation between the massive and the massless is what gives the universe its structure. If light had mass, it would not be able to travel vast distances instantly. From its perspective, it would be slowed by gravity. It would clump together. The universe would be a dark, sluggish place. Conversely, if we had no mass, we would instantly explode into light speed. We would not be able to form atoms, molecules, or biological cells. We would not have thoughts, for thoughts require time to process. We would simply be a flash of energy expanding forever. So, in a strange way, our inability to reach the speed of light is what makes existence possible. We need mass to exist. We need to be slow. We need to be left behind by the light so that we can have a place to live and a time to experience. The burden of mass is the price of admission for being alive. When you visualize the universe now, imagine it as a vast ocean of space-time. Matter, the galaxies, the stars, the planets are like islands or slow-moving icebergs, drifting leisurely through the currents of time. Light is the wind that whips between them, connecting them, touching them, but never staying with them. Light is the messenger that flies between the islands, carrying the image of one to the other. It knows the whole ocean because it crosses it instantly, while the islands are isolated, locked in their own slow temporal bubbles. The photon that strikes your eye has traveled from a star that may have died 1,000,000 years ago. That photon spent 0 time on the journey. But you, the observer, spent 1,000,000 years evolving, waiting, and being born just in time to catch it. It is a meeting of two completely different scales of reality: the eternal, instant flash of energy and the slow, enduring persistence of matter. This is the ultimate trade-off of the cosmos. To be matter is to have a history, a memory, and a future, but it is to be trapped in the slow lane. To be light is to be free, instant, and everywhere. But to be without a history, without a moment of rest, we look at the light and envy its speed, its freedom from time. But perhaps, if light could think, it would envy our ability to stop, to linger, to experience a moment not as an infinite streak of existence, but as a distinct, precious second in time. We tend to think of space as an empty stage, a rigid, unchanging box where the drama of the universe plays out. In this classical view, if you remove all the stars, planets, and atoms, you are left with a static grid of nothingness. But Einstein forced us to abandon this comfortable idea. He showed us that space is not a stage. It is an actor. It is a physical substance, a fabric that can be stretched, twisted, knotted, and torn. It is pliable. This realization leads us to the heart of general relativity, the relationship between matter and geometry. Imagine for a moment that the vacuum of space is a vast, invisible sheet of rubber pulled tight in all directions. If you place a bowling ball representing our sun in the center of this sheet, the rubber dips. It curves downward, creating a valley. Now, if you roll a marble representing Earth past the bowling ball, it won't move in a straight line. It will follow the curve of the dip, circling around the depression. To the marble, it feels like a force is pulling it in, but in reality, it is simply following the shape of the surface it is rolling on. This is gravity. It is not a mystical tether, it is geometry. This model explains why light, despite having no mass, still obeys gravity. When a beam of light travels from a distant galaxy to Earth, it wants to take the straightest path possible. But if that path takes it near a massive cluster of galaxies, the rubber sheet of space is warped deep down. The light must follow that warp. It dips into the valley and climbs back out. To our telescopes, the light appears to bend. We call this phenomenon gravitational lensing. It turns massive galaxy clusters into cosmic magnifying glasses, bending and focusing the light from objects behind them that would otherwise be too faint to see. We are literally seeing the universe through the warped lenses of space itself. But what happens when you put too much weight on the rubber sheet? What if you concentrate a massive amount of matter into a space smaller than a city? The fabric doesn't just dip, it effectively ruptures. It stretches infinitely downward, forming a bottomless well. This is a black hole. In the vicinity of a black hole, the curvature of space becomes so extreme that the rules of geometry break down. The slope of space becomes so steep that to climb out of it, you would need to travel faster than light. Since nothing can travel faster than light, nothing can climb out. This boundary, the point of no return, is called the event horizon. It is not a solid wall. It is simply the line where the slope of space becomes vertical. If you were an astronaut falling toward this horizon, you would witness the universe behaving in terrifying ways. As gravity intensifies, it doesn't just pull on your body, it pulls on the light around you. The image of the universe above you would begin to shrink, compressing into a smaller and smaller circle of light, as if the sky were closing up. Meanwhile, time for you would begin to separate violently from time in the rest of the universe. To a distant observer watching you fall, you would appear to slow down. As you touch the horizon, you would seem to freeze, fading slowly into redness, never actually crossing the line. But from your perspective, you would cross it instantly, plunging toward the center, the singularity. The singularity is the ultimate mystery of physics. It is a point where the fabric of space is crushed to zero volume and infinite density. Here, the rubber sheet analogy fails because the math yields infinity, which is nature's way of saying we do not understand what is happening. At the singularity, space and time cease to exist as meaningful concepts. It is a tear in the logic of reality. This malleability of space is not limited to black holes. It affects the entire cosmos. We know that the universe is expanding. The fabric of space between galaxies is stretching, carrying them apart like dots on a balloon being inflated. This means that light traveling through the universe is being stretched too. A photon leaving a star billions of years ago might start as high-energy blue light. But as it spends eons traversing the expanding fabric of space, its wavelength is pulled apart, shifting it into red, then infrared, and eventually into radio waves. This is why the afterglow of the Big Bang, the cosmic microwave background, is detected as microwaves. It is the oldest light in the universe, stretched out by the expansion of space itself until it has become cold and faint. This paints a picture of a universe that is incredibly dynamic. It is not a quiet void. It is a turbulent ocean of space-time, rippling with gravitational waves. When two black holes collide, they don't just crash like rocks. They ring the universe like a bell. They send out shock waves that stretch and squeeze the space we are sitting in right now. These waves pass through the Earth, stretching our planet by a fraction of the width of an atom. We have built detectors, giant lasers miles long, to listen for these tiny trembles. We are effectively listening to the vibrations of the fabric of space. So, when we ask, what does light see? We must remember that light is navigating this shifting, heaving terrain. It is surfing the waves of gravity, dipping into the wells of stars, and spiraling around the edges of black holes. It is tracing the invisible contours of the universe. By catching this light, we are mapping the topography of the dark. We can find invisible black holes by watching how they bend the light of stars behind them. We can weigh entire galaxies by measuring how deep they dent the fabric of space. In this view, the distinction between space and stuff blurs. Matter tells space how to curve. Space tells matter how to move. They are locked in a continuous feedback loop, and light is the thread that weaves through it all, ignoring the passage of time but strictly following the curves of space. It reveals that our reality is fragile. The solid ground beneath our feet, the steady sky above, are just local illusions. In truth, we are adrift on a flexible, warping, expanding membrane that can, under the right conditions, fold up and trap light forever. This fragility is unsettling, but also beautiful. It means the universe is malleable. It suggests that the laws of physics are not rigid bars of a cage, but the fluid dynamics of a vast ocean. And we, with our short lives and heavy bodies, are learning to read the currents. We are learning that while we are stuck on the slow-moving islands of matter, we can use the light to see the shape of the ocean floor. We can look at the edge of a black hole and see the silhouette of the point where time ends. We can look back to the beginning and see the moment where space began to stretch. Understanding this flexibility changes our relationship with the cosmos. We are not just inhabitants of a box. We are participants in a structure that reacts to our presence, however slightly. Every atom in your body creates a tiny dent in space. You are, in the most literal sense, bending the universe around you. It is a small distortion, imperceptible to the eye, but to the fabric of space-time, it is real. You are part of the geometry. Light acts as the primary narrator of the universe, but it is an unreliable one. It tells us what is happening, but rarely when it is happening. Because light has a finite speed, it turns the entire cosmos into a historical archive. When you gaze at the Andromeda Galaxy, you are not seeing it as it exists today. You are seeing it as it was 2.5 million years ago, when early hominids were just beginning to walk upright on Earth. If that galaxy were to vanish this instant, we would continue to see it shine for another 2 million years. The light is already on its way, carrying a message that is outdated before it even arrives. This creates a fundamental barrier known as the observable universe. There is likely much more universe beyond what we can see, but the light from those distant regions has not had enough time since the Big Bang to reach us. We are trapped in a bubble of information defined strictly by the speed of light. This is the first boundary, the boundary of time and distance. But there is a second, more absolute boundary, a place where light does not just take a long time to arrive, but where it can never leave. This is the event horizon of a black hole. We previously discussed how mass bends space. At a black hole, this bending becomes catastrophic. To understand why light gets trapped, imagine space not as a static floor, but as a flowing river. Near a black hole, space itself is flowing inward, like a waterfall cascading over a cliff. As you get closer to the edge, the current of space flows faster. At the event horizon, the space is flowing inward at the speed of light. Since light travels through space at a constant speed, if the space it is traveling through is falling backward faster than the light can swim forward, the light loses. It is swept down the drain. For an observer watching from a safe distance, this creates a haunting visual effect. If you watched an object fall into a black hole, you would never actually see it cross the line. As the object approaches the horizon, the light coming from it has to struggle against the immense gravitational pull to reach your eye. This struggle drains the light of its energy. The image of the object becomes redder and redder, a phenomenon called gravitational redshift. Eventually, the light becomes infrared, then radio waves, and finally, it fades into total silence. The object appears to freeze on the edge of forever, fading out of existence, while in reality, it has already plunged to its destruction. Inside the horizon, all paths lead downward. In our normal lives, we have freedom of movement in space. We can go left, right, forward, or backward, but we are forced to move forward in time. Inside a black hole, this geometry flips. The direction toward the center becomes as inevitable as tomorrow. You can no longer avoid the singularity any more than you can avoid next Tuesday. The singularity represents the ultimate breakdown of our understanding. It is a point where density becomes infinite and the laws of physics result in errors. Light, which usually defines the size and shape of our reality, is rendered mute here. It is a region of cosmic censorship. However, the strangeness of light is not limited to the massive scales of gravity and black holes. If we zoom in past the stars, past the planets, down to the microscopic scale, we encounter a boundary of a different kind. We enter the realm of quantum mechanics, and here, light behaves in ways that seem to violate the basic logic of the world. For centuries, classical physics painted a picture of a tidy, predictable universe. We believed light was a wave, similar to ripples moving across a pond. This made perfect sense. When you shine two beams of light at each other, They pass through and interfere, creating patterns of bright and dark bands, just like water waves crashing together. This wave nature explained optics, colors, and rainbows. It was elegant and consistent, but in the early 20th century, a series of experiments shattered this view. Physicists discovered that when light hits a metal surface, it knocks electrons loose, a phenomenon known as the photoelectric effect. If light were purely a wave, a dim light shining for a long time should eventually build up enough energy to knock an electron loose. But that didn't happen. Instead, faint light did nothing, while higher frequency light worked instantly. Albert Einstein realized that the only way to explain this was to assume light was not just a continuous wave, but a stream of discrete packets, bullets of energy. We call them photons. This birthed the central paradox of modern physics: wave-particle duality. Light is not just a wave, and it is not just a particle. It is somehow both, and it is neither. This is not a semantic trick. It is a fundamental blurring of identity. When light travels through space, it spreads out like a wave. It bends around corners. It passes through narrow slits and fans out. But the moment it interacts with matter, when it hits a camera sensor or a retina, it strikes as a single, localized particle. It travels as a probability, but it arrives as a certainty. Imagine a fog. When you look at it from a distance, it appears to be a smooth, continuous cloud. But if you walk into it and look closely, you see it is made of billions of tiny, distinct water droplets. Light is somewhat like this, but with a twist. It is the fog and the droplet, depending on how you look at it. This introduces the concept of the quantum haze. In our macroscopic world, things have definite properties. A car is either in the garage or on the street. It has a specific speed and a specific location. But in the quantum world of light, these certainties evaporate. A photon does not have a strict position until you measure it. Before that measurement, it exists in a superposition, a ghost-like state where it is effectively in multiple places at once. It is exploring every possible path simultaneously. This is best illustrated by the famous double-slit experiment. If you fire a stream of photons at a barrier with two slits, and you place a screen behind it, you will see an interference pattern, a series of stripes that suggests the photons went through both slits at once and interfered with themselves like waves. However, if you place a detector at the slits to see which one the photon actually goes through, the pattern disappears. The photon suddenly decides to act like a bullet, going through only one slit. The act of observation forces the light to choose an identity. The haze of probability collapses into a single point of reality. This implies that the universe, at its most fundamental level, is granular and probabilistic. It is not a clockwork mechanism that ticks precisely. It is a casino of probabilities. Werner Heisenberg codified this with his uncertainty principle. He showed that there is a hard limit to what we can know. You cannot know both the position and the momentum of a quantum particle with perfect precision. The more you know about where a photon is, the less you know about where it is going. This is not a failure of our instruments. It is a feature of the universe. Reality, at that scale, is inherently fuzzy. So, when we ask what light sees, we are asking a question that bridges two incompatible worlds. On the cosmic scale, light traces the curves of gravity, obediently following the warped fabric of space-time into black holes. It is the victim of geometry. But on the microscopic scale, light is a shapeshifter. It exists in a cloud of potential, refusing to be pinned down until it hits something. This duality is difficult to accept because we live in the middle scale, too small to feel the curvature of space directly, and too big to see the quantum fuzziness. We rely on light to bridge the gap. We use it to peer into the crushing gravity of a black hole, and we use it to probe the structure of the atom. Light is the only thing that speaks both languages. It is the currency of the universe, trading energy between the very big and the very small. But the mystery deepens. If a single photon can exist in a state of uncertainty, what happens when you have two? What happens when two particles of light interact and then separate? This brings us to the edge of the most counterintuitive phenomenon in all of physics. It suggests that the separation we see between objects, the distance between here and there, might be an illusion. Imagine two photons are generated from the same energetic event. Perhaps an atom emits them simultaneously in opposite directions. According to the laws of conservation, these two photons are linked. If one spins up, the other must spin down to keep the total balance of the universe zero. They fly apart. One travels to the left, the other to the right. They travel for miles, or perhaps light years. They are now separated by a vast ocean of space. In our classical understanding, they are now two separate independent objects. If you touch one, the other should not feel it. But quantum mechanics predicts something disturbing. It says that these two photons remain connected, regardless of the distance. They are entangled. They share a single existence. If you measure the first photon and find it spinning up, the second photon, instantly faster than the speed of light, will snap into the down state, even if it is on the other side of the galaxy. It is as if they never truly separated. The space between them, which we think is real and vast, means nothing to them. This leads us to a concept that Einstein called spooky action at a distance, and it challenges the very bedrock of how we define location and separation. We have spoken of light as a traveler, moving across the void to deliver messages. But quantum mechanics suggests a stranger possibility. Perhaps the universe does not always need to send a traveler to deliver a message. Perhaps, at the deepest level, the universe is already connected, bypassing the need for transit entirely. This brings us to the phenomenon of quantum entanglement, a concept so radical that it unnerved the greatest minds in physics, including Albert Einstein. To understand the weight of this, we must look at a specific property of particles called spin. Imagine a photon not just as a dot of light, but as a tiny spinning top. It can spin in one of two states, up or down. Now, in the quantum world, until you measure the photon, it is spinning both up and down simultaneously. It is in that hazy state of superposition. Now, generate two photons from the same source so that they are entangled. The laws of physics demand balance. If one photon eventually decides to spin up, the other must spin down to cancel it out. This is not controversial. The controversy begins when you separate them. Send one photon to a laboratory in New York and the other to a laboratory on Mars. They are separated by millions of miles of empty space. According to classical logic, they are now two independent objects. But if the scientist in New York measures her photon and finds it is spinning up, the photon on Mars instantly snaps into the down state. This happens instantaneously, zero time delay, faster than light. It is as if the two photons are not two separate particles at all, but the same particle stretched across space. Einstein mocked this as spooky action at a distance. He believed there must be a hidden wire, a hidden variable connecting them that we just couldn't see. He was wrong. Decades of experiments, from Bell tests to satellite communications, have proven that the connection is real. The space between the particles, seemingly vast and empty, effectively does not exist for them. This leads to a staggering implication about the nature of space itself. We usually think of space as a pre-existing container, a box that we put stars and atoms into. But some modern physicists, inspired by entanglement, are proposing a different idea: emergent spacetime. The theory suggests that space is not the background stage. It is the result of the entanglement. The threads of connection between particles might be stitching the universe together. Where there is entanglement, there is closeness. Where there is no entanglement, there is separation. In this view, the distance light travels is not a fundamental barrier. It is simply a measure of how entangled two regions are. If this hypothesis holds true, then the universe is not a vast cavern of emptiness. It is a network. It is a web of relationships. Light, traveling at its finite speed, is merely navigating the geometry created by these deeper quantum connections. We see a lonely beam of light crossing a void, but beneath the surface, the fabric of reality might be woven tight, leaving nothing truly isolated. However, while the quantum world hints at deep connections, the macroscopic universe imposes strict isolations. We return now to the concept of horizons, the ultimate walls of our reality. We have discussed the event horizon of a black hole, but we must distinguish it from another, equally terrifying boundary: the cosmic horizon. The event horizon is a local trap. It is a specific place you can choose to avoid. It is the point of no return around a singularity where gravity is the warden. But the cosmic horizon is everywhere. It is the limit of the observable universe. Because the universe is expanding, and that expansion is accelerating, galaxies are being pushed away from us. There are galaxies so far away that the space between us and them is stretching faster than the speed of light. Think about what that means. A photon leaves a star in one of those distant galaxies, heading toward Earth. It travels at the maximum speed limit of the universe. But the road beneath it, space itself, is stretching backward faster than the photon can run forward. It is like running on a treadmill that is speeding up. The photon will never reach us. It is traveling, but it is losing ground. This creates a sphere of silence around us. Beyond a certain distance, events are happening right now. Stars are exploding. Civilizations might be rising, but we will never know. Their light is forever disconnected from our future. We are slowly being isolated in a pool of darkness. As the eons pass and the expansion accelerates, more and more galaxies will slip across this horizon, vanishing from our sky forever. Future astronomers, billions of years from now, might look up and see only our own local galaxy, floating in an empty void, with no evidence that a wider universe ever existed. They would be trapped inside a cosmic horizon that has shrunk the known world down to a single island. These horizons, both the black hole's edge and the cosmic limit, force us to confront the information paradox. In physics, information is supposed to be indestructible. If you burn a book, the information isn't technically lost. It's scrambled into ash and smoke. If you could collect every particle of ash, you could theoretically reconstruct the book. But what happens when a book falls into a black hole? The book crosses the horizon. It is gone from our universe. Eventually, according to Stephen Hawking, the black hole evaporates through radiation and disappears. Where did the information of the book go? Did it vanish? If so, it breaks the fundamental laws of quantum mechanics. This conflict between gravity, which says information can be destroyed, and quantum mechanics, which says it cannot, is the biggest war in modern physics. This brings us to the most mind-bending solution proposed to solve this war: the holographic principle. Imagine a soup can. The soup inside is a three-dimensional mixture of vegetables and broth, but the label on the outside is a two-dimensional sheet of paper. Yet, the label contains all the information about what is inside the can. You can know the soup just by reading the surface. The holographic principle suggests that a black hole, and perhaps the entire universe, works the same way. When an object falls into a black hole, maybe its physical 3D body is crushed, but its information, the data that describes it, gets plastered onto the surface of the event horizon. It becomes a 2D coding on the sphere. The horizon acts like a hard drive, storing the data of everything that has ever fallen in. If this math is correct, it implies something radical about our own reality. It suggests that the three-dimensional world we occupy, the depth of space, the height of mountains, the distance to the stars, might be a projection. We might be a hologram. The real information of the universe might exist on a distant, two-dimensional boundary surface, and our reality is just the projection of that data into 3D space. Much like a hologram on a credit card looks 3D but is actually flat. In this scenario, light is the mechanism of projection. It is the carrier that translates the data from the boundary into the experience of volume and depth. The horizon, then, is not just a wall. It is the source code. It is the screen upon which the movie of the universe is written. This recontextualizes everything we have discussed. We asked, what does light see? In the holographic view, light doesn't just see the universe. Light is the readout of the universe. It is the transmission of data from the 2D surface to the 3D bulk. The vast distances that light travels, the billions of years it spends in transit, might be an illusion of perspective, a side effect of the projection. So we stand between two extremes. On one hand, we have entanglement, which suggests that distance is an illusion because everything is connected at a single point. On the other hand, we have horizons, which suggests that distance is absolute and insurmountable. Light is caught in the middle. It is the thread trying to stitch the hologram together. It travels from the event horizon, carrying the faint, red-shifted signature of the gravity well. It travels from the cosmic horizon, bringing the last gasps of ancient galaxies before they disappear. It is the only thing that connects the here to the there, the now to the then. It is navigating a universe that might be a web of quantum threads, or a holographic projection, or a rapidly tearing fabric. And yet, for the photon, none of this complexity manifests as a struggle. It does not worry about the paradox of information. It does not panic as the treadmill of space speeds up. It simply obeys the one rule it knows: move at. Traces the geometry of the universe faithfully. If space stretches, the photon stretches. If space knots, the photon follows the knot. It is the perfect, passive witness. As we look up tonight, we must realize that our view is curated. We are only allowed to see the light that has survived the journey. We see the photons that escaped the black holes, the photons that outran the expansion, the photons that weren't blocked by dust. We are seeing a survivor's map of the cosmos. The dark patches in the sky are not just empty space. They are the silences where the light failed to reach us, the places where the universe keeps its secrets. The horizons are the edges of our cage, but they are also the walls where the story is written. We have spent much time discussing light as a traveler, crossing the void with impunity. But to truly understand the character of light, we must examine the rare moments when it is conquered. We must return to the event horizon, but this time, let us look not at the darkness inside, but at the impossible geometry taking place just outside the edge. This is the realm where light does not simply travel, it dances on the precipice of destruction. Surrounding a black hole, at a distance of 1.5 times the Schwarzschild radius, exists a region known as the photon sphere. This is one of the most precarious places in the universe. Here, gravity is so intense that it pulls light into a perfect orbit. If you were standing in this region, you would not just see the black hole in front of you, you would see the back of your own head. Photons reflecting off your back would travel all the way around the black hole in a circle and return to hit your eyes. You would be effectively looking at a 360-degree panoramic history of your own existence, looping endlessly in the gravity well. This creates a visual paradox. A black hole is an object defined by its ability to swallow light, yet it is often surrounded by the brightest displays in the cosmos. As gas and dust fall toward the horizon, they do not drop straight in. They spiral, forming a flattened band called an accretion disk. Friction within this disk heats the material to millions of degrees, causing it to shine with a ferocity that outstrips entire galaxies. This leads to a jarring contrast. The black hole is a silhouette of absolute nothingness, framed by a halo of blinding brilliance. The gravity is so strong that it bends the light from the back of the disk up and over the top of the shadow, creating a ring of fire that appears to stand upright. Light here is being knotted, folded, and tortured by the warping of spacetime. But let us leave this violent, localized trap and turn our attention to a different kind of light. A light that is not fighting to escape a black hole, but has been traveling freely for longer than the Earth has existed. If you could turn off every star, dim every galaxy, and extinguish every supernova, the universe would not be completely black. There is a faint, pervasive hum of energy that fills every cubic centimeter of space. It is the oldest ghost in the creation. We call it the cosmic microwave background, or CMB. To understand this light, we must rewind the clock to the very beginning. Approximately 13.8 billion years ago, immediately after the Big Bang, the universe was not the cold, dark vacuum we know today. It was a screamingly hot, dense soup of particles. It was a plasma, a chaotic storm of protons, neutrons, and electrons, tearing around at incredible speeds. In this primordial era, light existed, but it was a prisoner. A photon could not travel more than a microscopic fraction of an inch before it slammed into a loose electron. It would bounce off, change direction, slam into another electron, and bounce again. Imagine trying to shine a flashlight through a dense, glowing fog. The beam doesn't go anywhere, it just scatters. For the first 380,000 years of its life, the universe was opaque. It was a glowing wall of white-hot fog. Light was trapped in a pinball machine of matter, unable to carry a message, unable to stream freely. Then, the universe cooled. As the expansion of space stretched the cosmos, the temperature dropped below 3,000 degrees Kelvin. This was the tipping point. It allowed protons to capture those frantic electrons, binding them into stable hydrogen atoms. This event is known as recombination. Suddenly, the loose electrons, the obstacles that had been blocking the light, were swept up into atoms. The fog lifted. The universe became transparent. In that instant, trillions of photons were released from their captivity. They broke free from the plasma and began to stream outward in every direction. This moment is often called the surface of last scattering. The light you see from the CMB is that exact flash of freedom. It is a snapshot of the infant universe, taken just 380,000 years after the moment of creation. It has been traveling through the void ever since, passing through the epochs of star formation, witnessing the birth of galaxies, and finally arriving at our detectors on Earth today. However, this light does not look the way it did when it started. When it began its journey, it was high-energy visible light, a blinding orange-white glow. But over the course of 14 billion years, the space it traveled through has expanded. We discussed earlier how the expansion of the universe stretches the wavelength of light. This primordial light has been stretched so much by a factor of about 1,100 that it has been pulled completely out of the visible spectrum. It has been shifted down into the microwave regime of the electromagnetic spectrum. It is cold, invisible, and low energy, but it is everywhere. If you have an old analog television set with rabbit ear antennas, you can witness this ancient light yourself. When you tune the TV to a channel with no broadcast, you see static, that chaotic, flickering snow on the screen. About 1% of that static is caused by the cosmic microwave background. The antenna is picking up photons that were born in the Big Bang, stretched by 14 billion years of cosmic expansion, and are now ending their journey by dancing on your screen. You are literally watching the afterglow of the creation event. This light is not just a curiosity, it is a map. When scientists launched satellites like COBE, WMAP, and Planck to scan this background radiation, they found something profound. The glow is almost perfectly uniform. It is the same temperature, 2.7 degrees Kelvin above absolute zero in every direction. But it is not perfectly uniform. There are tiny microscopic fluctuations. Some spots are 1/100,000th of a degree hotter. Others are 1/100,000th of a degree colder. These tiny ripples are the baby picture of the universe. They represent slight differences in the density of the primordial plasma. The slightly hotter, denser spots had a little more gravity than the cooler, less dense spots. Over billions of years, that extra gravity pulled in more matter. These tiny clumps grew and grew, eventually collapsing to form the very first stars and galaxies. The vast cosmic web of galaxy clusters we see today, the magnificent structure of the universe, grew from these imperceptible seeds imprinted in the ancient light. If the cosmic microwave background had been perfectly smooth, gravity would have had no toehold. Matter would have remained evenly spread out forever. There would be no stars, no planets, and no us. We owe our existence to these tiny imperfections in the first light. So, when we talk about what light sees, we must acknowledge that this ancient light has seen everything. It is the ultimate witness. It was there before the first star ignited. It drifted through the dark ages of the cosmos. It flowed around the first black holes. It is currently streaming through your body as you listen to this. We are swimming in a sea of fossilized photons. It connects us to the origin in a way that nothing else can. Looking at a star is looking at the present or the recent past. Looking at the CMB is looking at the boundary of time itself. It is the wall of fire that marked the beginning of the transparent universe. Beyond that wall, our telescopes cannot see, because before that moment, light was not free. The cosmic microwave background is the oldest visual record we can ever possess. It is the horizon of our history. This realization shifts our perspective on the darkness of space. We often think of the night sky as black, punctuated by points of light. But if your eyes could see microwaves, the night sky would not be dark at all. It would be a glowing canopy of energy, shining with the uniformity of the early universe. The darkness is an illusion caused by the limitations of our biology. In reality, we are living inside the cooling remnants of the Big Bang. The fire has died down, but the embers are still glowing all around us. This ancient light also serves as a cosmic frame of reference. In a universe where all motion is relative, where you can't tell if you are moving or if the other car is moving, the CMB provides a unique anchor. By measuring the Doppler shift of this background radiation, seeing if it looks slightly hotter in one direction and cooler in the opposite, we can actually measure our absolute speed through the universe. We know that our solar system is moving at about 370 kilometers per second relative to this primordial glow. It is the closest thing we have to a fixed stage in a universe of relativity. As we ponder the journey of this light, we are faced with the immense scale of time. These photons have not interacted with anything for 14 billion years. They have threaded the needle between galaxies, avoided the gravitational traps of black holes, and missed every atom of dust in the void, just to strike the detector of a telescope on Earth today. It is a journey of improbable luck, and it reminds us that light is not just a tool for seeing. It is the physical connective tissue of the cosmos. It binds the beginning to the present. It turns the universe from a collection of isolated events into a coherent story. Without this light, we would be amnesiacs, awake in a vast room with no memory of how we got there. With it, we can trace our lineage back to the first spark. We have spoken at length about light as a physical entity, a wave, a particle, a speed limit, but we must now pivot to perhaps its most intimate role, light as a storyteller. In the grand archive of the cosmos, light is the ink. Every event that has ever occurred in the visible universe has released a stream of photons, sending a visual report out into the void. These reports do not decay. They do not fade with time. They simply travel, expanding outward in a sphere of information that grows larger with every passing second. This means the universe is not just filled with stars and galaxies. It is filled with memories. The empty space between worlds is actually thick with the history of everything that has ever happened, streaming past us in silence. If you had a telescope powerful enough and could teleport instantly to a point 65 million light years away from Earth, and you pointed that telescope back at our planet, you would not see cities or highways. You would see the continents arranged differently. You would see dinosaurs roaming the lush jungles of the Cretaceous period. You would see the asteroids striking the Yucatan Peninsula. That light, the image of the dinosaurs' extinction, is not gone. It is still out there, 65 million light years away, racing deeper into the cosmos. The history of our world is not lost. It is simply traveling away from us at the speed of light. This concept turns the universe into a three-dimensional video recording. Nothing is ever truly erased. It just moves beyond our reach. We are constantly broadcasting our existence to the stars, layer by layer, moment by moment. But light does more than just carry images of the past. It carries the physical blueprint of the objects it touches. This is the science of spectroscopy, the art of reading the hidden language of color. When a beam of light leaves a star, It passes through the star's outer atmosphere. The atoms in that atmosphere, hydrogen, helium, carbon, oxygen, absorb specific wavelengths of light, leaving behind dark gaps in the rainbow of the spectrum. These gaps are like barcodes. By reading these barcodes, astronomers can stand on a small rocky planet called Earth and know with absolute certainty what a star a billion miles away is made of. We can determine its temperature, its mass, its age, and even how fast it is spinning, all by decoding the subtle shifts in the light it sends us. We can look at the atmosphere of a planet orbiting a distant sun and detect water vapor or methane potential signatures of life just by analyzing the faint glimmer of starlight filtering through its clouds. Light is not just showing us where things are, it is telling us what they are. It is data, rich and dense, waiting to be unzipped by our instruments. This flow of information is relentless. It creates a phenomenon we might call the cosmic library. Every photon is a book. Most of these books fly through empty space, unread, eventually hitting a random dust grain or fading into the cosmic horizon. But occasionally, a tiny fraction of them hits a very specific target, the retina of a human eye. This brings us to the miracle of perception. We often take sight for granted, assuming that we open our eyes and the world simply is. But vision is a complex act of reconstruction. The world outside your skull is dark and silent. It is filled with electromagnetic radiation of various wavelengths, but it has no intrinsic color or brightness. Those are qualities created entirely inside your brain. When a photon strikes the back of your eye, it hits a molecule called rhodopsin. This collision triggers a chemical chain reaction, converting the energy of the light into an electrical impulse. That impulse travels down the optic nerve to the visual cortex at the back of your brain. There, in the darkness of your skull, your brain interprets these signals and paints a picture. Red is not a property of a rose. Red is your brain's way of interpreting a wavelength of roughly 700 nanometers. Blue is the sensation of 450 nanometers. The vibrant, colorful world you perceive is a simulation, a user interface built by your mind to help you navigate the sea of radiation you live in. This interface is incredibly selective. The spectrum of light is vast, ranging from giant radio waves the size of buildings to tiny gamma rays smaller than atomic nuclei. Our eyes can detect only a tiny sliver in the middle, the visible spectrum. We are blind to the radio waves carrying our music, the microwaves heating our food, the X-rays used by doctors. If our eyes were tuned to radio waves, the sky would be filled with giant, glowing bubbles of ancient supernova remnants. If we could see gamma rays, the moon would look dimmer than the sun, but the universe would sparkle with violent bursts from collapsing stars. We see only what we have evolved to see, specifically, the wavelengths emitted most strongly by our own Sunday. This selective blindness shapes our reality. We think the sky is blue, but that is only because our atmosphere scatters blue light more than red. On Mars, with its thin, dusty atmosphere, the day sky is butterscotch, and the sunset is blue. Light behaves differently depending on the stage it plays on. It reflects, refracts, diffracts, and scatters. It is easily manipulated. Consider a mirage on a hot highway. The air near the asphalt is hotter and less dense than the air above it. Light traveling from the sky hits this layer of hot air and bends upward into your eye. You see a patch of blue on the road, and your brain, used to seeing blue on the ground only as water, interprets it as a puddle. The light didn't lie, it really did bend, but your perception was tricked. This reminds us that light is not a passive carrier of truth. It interacts with the environment. It gets twisted by heat, blocked by dust, and warped by gravity. So, when we look up at the night sky, we are engaging in an act of time travel and translation. We are catching ancient photons that have survived a journey of millions of years, filtering them through our biological lenses, and constructing a model of a universe that no longer exists in that form. The stars you see might have burned out eons ago. The nebulae might have dispersed. You are admiring ghosts. But there is a profound beauty in this delay. Because light takes time to travel, we can see the history of the universe unfold. If light traveled instantly, the sky would just be a snapshot of now. We would know nothing of the Big Bang, nothing of the evolution of galaxies. The finite speed of light is what allows us to be archaeologists of the cosmos. By looking farther away, we look deeper into the past. We can trace the lineage of the universe from its chaotic infancy to its structured maturity, layer by layer, just by looking deeper into the dark. And we are part of this stream. As you stand under the stars, you are emitting infrared light, heat radiation. Those photons are leaving your body, traveling up through the atmosphere, and escaping into space. They will travel forever, or until they hit something. 1 billion years from now, a photon that left your skin tonight might strike a dust grain in a distant nebula, slightly warming it. Your physical presence on Earth is fleeting, but your radiative signature is eternal. You are writing yourself into the memory of the universe, one photon at a time. In this sense, we are not just observers of the light, we are sources. We are glowing creatures in a glowing world, exchanging energy with the cosmos in a continuous, silent dialogue. The boundary between us and the universe blurs when you view it through the lens of light. We are made of atoms cooked in stars, and we emit light that returns to the stars. It is a cycle of energy and memory that has no beginning and no end. So the next time you close your eyes, remember that you are shutting out the universe's broadcast, but when you open them, you are letting the history of the cosmos flood in. You are allowing the vibrations of electromagnetic fields, generated by nuclear fires trillions of miles away, to touch a nerve in your body and spark a thought in your mind. That connection, tenuous, delayed, but real, is the closest we can get to touching the infinite. We often speak of the sky as being blue, as if blueness were a physical layer of paint applied to the atmosphere. But if you could fly up and collect a jar of air from the upper stratosphere, it would be perfectly transparent. The blue is not a substance. It is an event. It is the result of a collision between sunlight and the gases of our atmosphere. Sunlight appears white to us, but it is actually a packed suitcase containing every color of the rainbow. As this light slams into the nitrogen and oxygen molecules in our air, the shorter, punchier wavelengths, the blues and violets, are scattered wildly in every direction, bouncing like pinballs. The longer, lazier wavelengths, the reds and yellows, pass through largely uninterrupted. When you look up, your eye is catching the scattered blue light raining down from every part of the dome. The sky is not blue. The sky is a prism. This same logic applies to the dramatic reds of a sunset. When the sun sits low on the horizon, its light must travel through a much thicker slice of the atmosphere to reach you. By the time the light arrives, the blue photons have been scattered out completely, leaving only the survivors, the deep reds and oranges, to paint the clouds. Every sunset you witness is simply a record of light's struggle to reach you through the air. This reveals a fundamental truth about our visual reality. Color is not inherent to objects. It is, in a very literal sense, a rejection. Consider a leaf in a summer forest. We say the leaf is green, but biologically and physically, the leaf is absorbing red and blue light to fuel photosynthesis. It is devouring those energies. The only light it does not want, the light it spits back out, is green. So when you admire the verdant color of a forest, you are actually seeing the waste light that the trees have rejected. A red apple is red because it absorbs every other color but red. We define objects by the very light they refuse to keep. This distinction between what happens physically and what happens perceptually is crucial. The universe is filled with electromagnetic radiation, oscillating at different frequencies. That is the objective reality. But color is the subjective interface our brains have built to interpret that radiation. It is a user-friendly dashboard for the machine of the human body. Inside the human eye, on the retina, sit millions of specialized cells called cones. We possess 3 types, tuned roughly to red, green, and blue wavelengths. These are our 3 channels of reality. When light hits them, they fire electrical signals to the visual cortex. Your brain then acts like a master conductor, mixing these 3 signals to create the millions of hues you experience. Yellow, for instance, is not a unique signal. It is what your brain invents when the red and green cones fire simultaneously. But why do we see this way? Evolution does not care about beauty. It cares about survival. Our primate ancestors needed to distinguish a ripe red berry from a poisonous green leaf in a chaotic jungle. They needed to see the subtle flush of blood in a companion's skin to judge health or anger. Our color vision is a survival map, calibrated specifically to the environment of Earth. If we had evolved on a planet orbiting a dim red dwarf star, our eyes might be tuned entirely to the infrared. We would see heat as color. We would navigate a world of thermal gradients, where a living creature would glow brightly against the cold rock. To those beings, our visible spectrum would be a dark, useless void. This is not science fiction. It is happening right here on Earth. Consider the honeybee. Its vision is shifted toward the ultraviolet. To a human, a daisy is a simple white flower with a yellow center. But to a bee, that same flower is painted with a dazzling ultraviolet bullseye, invisible to us, guiding the insect to the nectar. The flower has evolved a secret signal that only its target audience can see. We are walking through a neon landscape of secret messages, completely blind to them because we lack the hardware to decode the signal. Or consider the mantis shrimp, a marine creature that possesses not 3 color receptors like humans, but up to 16. While we struggle to imagine a new color, the mantis shrimp lives in a kaleidoscopic explosion of sensory data we cannot even comprehend. It likely perceives differences between colors that look identical to us. It sees polarized light. It sees depth and texture in the light field itself. In the presence of such a creature, we are effectively colorblind. This leads to a humbling realization. There is no true image of the universe. There are only interpretations. The world you see, the rich blues, the vibrant greens, the deep shadows, is a specific simulation running inside the human skull. It is a consistent hallucination that we all share. If you were to remove every observer from the universe, take away every eye, every brain, every camera, what would happen to color? It would vanish. The rose would still reflect electromagnetic waves measuring 700 nanometers, but it would not be red. The ocean would still scatter short wavelengths, but it would not be blue. The universe would continue to be a swirling ocean of radiation, intense and energetic, but it would be silent and colorless. Color requires a consciousness to collapse the wave function of physics into the experience of sensation. It is a collaboration. The sun provides the energy. The object provides the filter, but you provide the paint. This does not make the world less real. In fact, it makes your presence in it essential. You are the mechanism by which the universe experiences its own beauty. Without perception, the cosmos is just math. With perception, it becomes art. And this perception creates a deep intimacy between you and the light. Every photon that strikes your eye has traveled a unique path. It may have been born in the fusion core of a star, spent 1,000,000 years fighting its way to the surface, traveled 8 minutes through the vacuum, filtered through the Earth's atmosphere, bounced off a blade of grass, and finally ended its existence on your retina. That specific photon died to give you a single speck of green. The image you see is the final resting place of countless tiny travelers. We also perceive time through light, though we rarely think of it that way. The color of the light changes the way we feel time passing. The harsh, blue-tinted light of midday signals activity and alertness. The soft, gold-shifted light of evening triggers the release of melatonin, telling our bodies to rest. We are circadian creatures, tethered to the rotation of our planet by the changing color of the sky. Artificial light has disrupted this ancient connection, bathing us in eternal noon, but our biology still hunts for the cues of dawn and dusk. Furthermore, light creates the very dimensionality of our world. Shadows are not just the absence of light, they are the anchors of shape. A sphere looks like a flat circle until a shadow gives it volume. A face looks unrecognizable without the subtle gradients of light that define the cheekbones and the jawline. Our brains are constantly calculating the angle of light, the depth of shadow, and the intensity of reflection to build a 3D model of the world. We are navigating a sculpture made of light. Even the blackness of space is a kind of color. We call it black, but it is really a depth. It is the visual experience of looking into infinity and seeing no return signal. When you look at the night sky between the stars, you are looking into the deep past, into the voids where no matter exists to scatter the light back to you. That blackness is the color of emptiness. So, as you move through your life, try to remember that you are not just looking at the world, you are actively constructing it. The red of the stop sign, the yellow of a lemon, the gray of a storm cloud, these are gifts given to you by your biology, triggered by the silent physics of the universe. We are living in a narrow slice of perception, sandwiched between the infrared and the ultraviolet, blind to the vast majority of the spectrum. But within that narrow slice, we have found infinite beauty. We have named the colors, painted our masterpieces, and defined our emotions by them. We feel blue, we see red, we are green with envy. We have taken the wavelengths of physics and turned them into the language of the human soul. Ultimately, light is the bridge. It bridges the gap between the cold, unfeeling matter of the universe and the warm, vibrant experience of being alive. It connects the fusion of stars to the firing of neurons. It turns a universe of quantum mechanics into a universe of morning skies and autumn leaves. It is the brush, the paint, and the canvas all at once. And you, the observer, are the gallery where the art is finally displayed. Without you, the lights are on, but nobody is home. With you, the universe becomes a place of color, a place of meaning, a place that can be seen. And maybe that is the quiet truth about color. It does not exist until we see it, and yet it is the most intimate bridge between the physics of light and the experience of living. It is light's way of reminding us that reality is not only out there waiting to be measured, it is also in here, painted across the canvas of the mind. This brings us to the most elusive phenomenon of all: consciousness. Consciousness feels like the one thing that belongs entirely to us. It is the quiet voice inside our minds, the private observer that thinks, feels, and wonders about the universe. It feels immaterial, separate from the cold, hard matter of stars and stones. And yet, when we peel away the layers of biology, when we look at the raw machinery of how the brain functions, there is an unsettling question waiting there. Could consciousness, this thing we treat as a ghost in the machine, be physically connected to light itself? It is not as strange as it first sounds. Every thought you have, every memory you summon, every flicker of awareness that passes through your mind happens because of electrical signals. Neurons fire. Tiny currents surge across cellular membranes. And in the spaces between those currents, electromagnetic fields are generated. These are fields that, just like light, are ripples in the fundamental fabric of the universe. The electricity in your brain, the glow of a lightning bolt, and the light from a distant star all spring from the same deep, universal structure of energy. When you see something, the process begins with light. Photons enter your eyes, strike the retina, and trigger a cascade of chemical reactions that transform into electrical impulses. Those impulses travel through a network of 86 billion neurons until, somehow, they ignite an experience. The color of a sunset, the recognition of a face, the sensation of being here. Light does not just reveal the outside world to you. It becomes the fuel for the internal process that constructs your reality. Without it, the mind would be a dark room, devoid of the raw data needed to build a picture of the present. But here is where the boundary between physics and awareness begins to blur. If light is the messenger that carries information from the universe to our minds, then isn't consciousness in some way tied to light's journey? Not just because we see light, but because the mechanism of thought relies on the same electromagnetic forces. The photons striking your eyes right now are part of an unbroken chain of events that began in the fusion cores of stars, traveled across empty space, and ended by lighting up a neural pathway inside your skull. The universe is touching you, physically, at the speed of light. There is an even stranger possibility that some physicists and neuroscientists have begun to explore. What if consciousness itself emerges from the same principles that govern light? We know that light does not experience time. From the perspective of a photon, every point along its path exists in the same eternal now. What if awareness, that strange, ungraspable feeling of existing in the present moment, shares something with that timeless quality? After all, consciousness does not move forward in discrete, ticking steps. You do not feel reality clicking by like frames on a film reel. You exist in a seamless flow, a continuous stream of now that never breaks. It is tempting to wonder if this sensation of flow is an echo of the way light moves through reality. Some theories, such as those involving quantum processes in the brain, suggest that the electrical rhythms of our thoughts might be harmonizing with the fundamental fields of the cosmos. It is not that our minds are literally made of light, but that the same underlying rules shape both. Your consciousness could be, in part, a pattern woven from the same energetic fabric that lets photons race across the galaxy. If this link exists, it implies something profound about our limits. If nothing in the universe can move faster than light, then perhaps even our thoughts, our perceptions, and our processing of reality are bound by that same cosmic speed limit. It would mean that our awareness is not floating above the universe, detached and superior. It is anchored in it. It is rooted in the same physical laws that guide the stars. Consciousness, in this view, is not a separate observer. It is another expression of the universe's energy, one more phenomenon bound by light's relentless, unchanging pace. And if that is true, then in every thought you have, in every moment of awareness, you are touching something far larger than yourself. You are part of the same story that began with the first burst of radiation at the dawn of time. Every neuron that fires in your brain, every photon that enters your eyes, every spark of perception is one more thread in the vast, unbroken web of energy that has been weaving itself for 14 billion years. We do not know for certain if consciousness is quantum in nature or if it is strictly biological. But even if we look at it purely through the lens of classical physics, the connection is undeniable. We are creatures of light. We consume it through our eyes to understand the world. We consume it through our food, which is just stored sunlight in plants to power our bodies. And, perhaps most beautifully, we give it back. This brings us to the concept of the conversation. If you could slow the universe down to a whisper, quiet enough to hear the smallest exchanges of energy, you might begin to sense a dialogue that never stops. It is not a conversation in words. It is the endless, silent exchange of photons. Every object in the universe is radiating. You are not just a sponge soaking up the world. You are a lighthouse. At this very moment, your body is warm. That warmth is not just a feeling, it is light. You are emitting infrared radiation, glowing with a power of roughly 100 watts. You are shining. Most of this light is absorbed by the clothes you wear, the chair you sit on, or the air around you, but some of it escapes. If you are standing outside on a clear night, looking up at the stars, the infrared photons leaving your skin travel up through the atmosphere. They slip through the gaps in the molecules of the air. They enter the vacuum of space, and once they are there is nothing to stop them. They will travel forever. 1 billion years from now, long after the Earth has changed, a photon that left your hand tonight will still be racing through the silence of the void. It will carry the thermal imprint of a living being who once stood on a small, rocky planet. It is a physical message that says, I was here, I was alive. In this way, we are constantly writing our autobiography in infrared ink on the canvas of the cosmos. We are joining the great conversation, adding our own quiet verses to the symphony of radiation that fills the universe. This conversation shapes the universe on every scale. Galaxies speak in light, stars broadcast their life stories in color and brightness. When a star dies, it shouts its last words in brilliant flashes. scattering photons across space to be picked up by anyone or anything that might be watching eons later. And we, with our telescopes and our eyes, are the listeners. When you look at the night sky, you are not simply watching a static picture. You are accepting a message. You are completing a circuit that has been open for millions of years. If photons could think, if they could be aware of their endless journey, they would see a universe without separations. They would see no difference between the star that emitted them and the eye that absorbed them. To a photon, the journey from the surface of Andromeda to your retina is instantaneous. There is no in-between. There is only the connection. They would see a universe where everything is touching everything else, stitched together by lines of sight and heat. If light could speak, its voice would not be loud. It has been talking for nearly 14 billion years without a single pause, carrying its message across the endless dark. And if we could hear it, truly hear it, perhaps it would not sound like words at all, but like something older and simpler, a language of movement and presence. It might begin by telling us where it came from. A photon born in the heart of a star might whisper of the crushing heat that forged it, the nuclear fires where matter and energy trade places in an endless dance. It might tell of the moment it escaped, breaking free from the furnace of its birth to begin its long flight outward. For billions of years, it has been traveling through space, never resting, never slowing. It might describe the galaxies it passed along the way, spiraling clusters of stars glowing in the blackness like lanterns on a sea without end. It might speak of the gravity wells of massive planets that tugged at its path, bending it ever so slightly but never stopping it. It might tell us about the vast gulfs of emptiness, stretches of space where it drifted alone for eons, unseen and untouched, until it finally found its way to an eye, a mirror, or a sensor waiting to receive it. And if light could speak, maybe it would laugh at our concept of distance. To us, 1 billion light years is an impossible chasm, but for light, there is no long journey. From its perspective, there was never any time in between. It would say, "I was there, and now I am here, and to me, they are the same place." This perspective forces us to rethink our own place in the cosmos. We often feel small, isolated on a tiny blue dot in a vast, indifferent void. But light tells a different story. It tells us that we are connected to the farthest reaches of space. The iron in our blood, the calcium in our bones, the carbon in our cells, all of it was forged in stars that exploded and sent their light and matter across the universe. And now, we use that matter to build eyes that can see the light and brains that can understand it. We are the universe's way of looking at itself. We are the mechanism by which the cosmos has become aware of its own light. Every time you look up, every time you wonder, you are participating in a cycle that has been running since the Big Bang. You are not just an observer. You are the destination that the light has been traveling toward all this time. And as we continue to gaze into the dark, waiting for the next message to arrive, we realize that the story is far from over. The conversation is still happening. The light is still coming. We have traveled a long way together, tracing the path of a photon from the violent furnace of the Big Bang to the quiet intimacy of the human eye. We have looked at black holes, entangled particles, and the illusions of color. But now, as we reach the end of this journey, we must turn our attention to the most important part of the story. We must talk about you. Throughout these discussions, we have treated light as something external, a messenger, a witness, a tool. But that distinction is not entirely true. To understand the final secret of light, we have to dismantle the barrier between the observer and the observed. We have to realize that you are not merely watching the show, you are the show. Consider for a moment the physical substance of your body. Look at your hand. Feel the weight of your bones, the rhythm of your blood, the heat of your skin. Where did all of this come from? It did not begin here on Earth. The hydrogen in the water of your cells is primordial. It was forged in the first 3 minutes of the universe's existence. But everything else, the carbon that builds your DNA, the calcium that hardens your skeleton, the iron that reddens your blood, has a much more violent origin. Billions of years ago, before the Earth existed, space was filled with clouds of pristine hydrogen gas. Gravity pulled these clouds together, crushing them until they ignited into stars. For eons, these stars burned, but they were not just burning, they were manufacturing. Inside their cores, under crushing pressure and heat, they were smashing simple atoms together to create complex ones. They were fusing hydrogen into helium, helium into carbon, and carbon into oxygen. These stars were cosmic alchemists, transmuting the raw stuff of the Big Bang into the building blocks of life. But that was not enough. As long as those elements remained trapped inside the star, they were useless. They were locked in a prison of gravity. For you to exist, the star had to die. And not just die quietly. It had to sacrifice itself in a cataclysmic explosion, a supernova. In that final fraction of a second, the star collapsed and then rebounded with enough force to outshine an entire galaxy. It tore itself apart, blasting those newly forged elements, the carbon, the oxygen, the iron, out into the void. Those clouds of enriched dust drifted through the galaxy for millions of years. Eventually, they clumped together again to form a new star, our sun, and a disk of rocky debris that became the Earth. And from that debris, life emerged. This means that quite literally, every atom in your body was once inside a star that exploded. You are made of stellar ash. You are a collection of atoms that have lived through the death of suns to come together for a brief moment to form you. But the connection goes deeper than just atoms. It is about energy. It is about light. When those ancient stars fused atoms together, they released energy in the form of light. That light radiated out into the universe, but some of that energy was locked into the chemical bonds of the atoms themselves. When you eat an apple, you are eating the energy of the sun, captured by a leaf and stored in sugar. When you breathe, you are burning that fuel, releasing the energy that was forged in a star 93 million miles away. This creates a profound realization. We are creatures of light. We are not solid, static statues. We are dynamic processes. We are rivers of energy that flow through a physical form. We consume light to survive, and we emit light to exist. This brings us back to the concept we touched on earlier, the idea that light is the universe's memory. If light never dies, if it only transforms, then nothing is ever truly lost. The light that bounced off your face when you were a child is still traveling through space today, carrying that image away from Earth at the speed of light. The heat you radiated yesterday is now a wave of infrared energy expanding into the solar system. In a universe defined by the conservation of energy, there is no such thing as deletion. There is only transformation. The energy that makes up your consciousness, the electricity that powers your thoughts, came from the cosmos and will return to the cosmos. We are borrowing our existence from the universe, and one day we will pay it back with interest. If light could speak, perhaps it would tell us not to be afraid of this cycle. It would say, I am the bridge between the beginning and the end. Think about the journey of a photon. It does not experience time. From the moment it is born to the moment it is absorbed, it exists in a single, unbroken now. To a photon, the birth of the universe and the death of the universe are happening simultaneously. It stitches all of history together into one fabric. And you, simply by being here, by being aware, are part of that fabric. You are the universe waking up. You are the cosmos looking in the mirror. For 14 billion years, the universe was blind, a vast ocean of radiation and matter moving in the dark. But then, it evolved eyes, it evolved minds, it evolved you. When you look up at the night sky, you are not a tiny, insignificant speck looking at a vast, uncaring void. You are the mechanism by which the void knows itself. The light from those stars has traveled for millions of years to reach you. If you were not there to see it, that journey would be incomplete. You are the destination. You give the light meaning. This changes how we feel about the dark. The darkness of space is not empty. It is waiting. It is a canvas waiting for light to paint it. And the silence of the cosmos is not a lack of sound. It is a space for listening. If we could listen closely to the light, if we could hear the message it has been carrying since the dawn of time, it might sound like a promise. It might say, you are not alone. You are woven into the tapestry of existence by threads that can never be broken. It would remind us that while our lives seem short, a flicker of a candle in a hurricane, our impact is eternal. The light we interact with, the gravity we exert, the energy we share, it all ripples outward forever. A kindness you do today releases energy that affects the world around you. A thought you have changes the electrical state of your brain, altering the electromagnetic fields in the room. You are constantly shaping the universe, even in the smallest ways. And maybe, in the end, that is the lesson of light. It is not about speed. It is not about distance. It is about connection. Light is the force that refuses to let anything remain isolated. It binds the electron to the proton. It binds the sun to the earth. It binds the galaxy to the eye. It creates a universe where everything touches everything else. So, as we come to the end of our time together, I want you to let go of the weight of the day. Let go of the worries about tomorrow. Let go of the feeling that you are separate from the world around you. Imagine for a moment that you can see the universe as light sees it. Imagine the walls of your room dissolving into a mist of atoms. Imagine the roof above you opening up to reveal the infinite depth of the sky. See the earth not as a solid rock, but as a glowing sphere of energy, humming with life, floating in a sea of stars. You are part of that glow. The same energy that ignited the Big Bang is beating in your chest right now. The same gravity that holds the Milky Way together is holding you to your bed. You are home. You have always been home. The light is not going anywhere. It will be here while you sleep, watching over the world, carrying messages from one side of creation to the other. It has been traveling for billions of years to find you, and now that it has, it can rest, and so can you. Close your eyes. Feel the quiet gravity of the planet supporting you. Feel the warmth of your own life. Listen to the silence, and know that it is not empty. It is full of the quiet, steady presence of a universe that has made a place for you. The stars are burning above. The earth is turning below. The light is traveling between them, stitching it all together in a web of endless connection. You are safe in that web. You are part of the light. Good night.